Hello, Vlog Nation. Okay. I don't know. I'm feeling. You've got me feeling like I should. Thou shall art do math or something today. So. All right. Let's talk about what we're about to get into. Cool. Let me finish writing this and then I'll put it up there. So let's talk about what we're getting into. We're getting into systems. So systems of linear equations and linear inequalities. Okay. So not yet. So turn and talk to your partner or someone you're sitting close to. What is a linear equation? 30 seconds. Go.
It's an equation that makes a line on a graph. Is that right, Mr. Ray?
We'll find out. All right, Brian. What did your partner say? Okay. What did you say? So can we be more intentional about what we're saying? So you said it's an equation that makes lines. Is it an equation that makes one line, or is it an equation that makes multiple lines?
Well, not like but I meant one line. No, one line, because like you got the dot, you don't make multiple.
So you were talking about like multiple points on a graph that are connected by one line.
Yeah.
Okay, does anybody agree with that?
That's crazy.
Nobody agrees with that? He's correct. So we all do agree, right? That a linear equation, okay, a linear equation is an equation that could represent a straight line on a graph. Yeah? So now turn to someone you're sitting close to and put our Chromebooks up and then talk about what a system of linear equations is. Good job. Yeah. What is it?
It is an almond that is covered in yogurt flavored lemons.
Yogurt flavored lemons. Well done. Good choice. Okay. Let's talk about it. I think there's a riveting discussion going on right here. So what's a system of linear equations? Oh, so sorry. Okay, now we're ready. That's perfect. Okay. Now, there is one specific thing that needs to go along with that. They share the same variables. Okay, so it's two or more linear equations on the same graph that share the same variables. Okay. So let's put that down. Two or more equations with the same variables on a graph. So, how is it possible for two lines on the same graph to share a similar value, a similar solution? So a solution on a line is anywhere that graph is touching, right? So if we have two lines on a graph, how is it possible for them to share the same value? What would have to happen?
If they're one of these things.
Maybe. The point xy where the two lines intersect. Okay, algebraically speaking, this point would make both equations true. Why are we calling this true? What do we mean? So if we plug in our x and we plug in our y to an equation, how would that sentence come out to be true? I would love some effort since you just had a 4-day weekend. Always. What makes an equation true? If I plugged in x and plugged in y to a linear equation, what makes that equation true? Why are we plugging it in? No, we are trying now. That's okay. So when we're saying we're trying to make an equation true, we're trying to balance it. Like we're saying this side equals this side. Okay, y equals x. Okay, the left equals the right. We're balancing it. So if I ask myself a question at the end of it, does 2 equal 2? I would say that that is true. So that solution that we plugged into that was a good solution. Okay, something that would be a not good solution is if I plug something in and it came out to be 2 equals -3. Hopefully we would all agree that 2 does not equal -3, and so that would not be a solution for that graph. Okay, so some different kinds of graphs that you'll see. Intersecting lines. Parallel lines. And this is just how this is represented. In actuality, you wouldn't see anything different, but same lines. Intersecting lines have how many solutions? Just one, where it intersects. Parallel lines have how many solutions? 0 solutions. And two lines that are the exact same have how many solutions? Infinite. Life hack. Okay, so for today, you're going to get lots of graphing review practice. Okay, so a couple of steps to keep in mind when you're graphing. Rewrite the equations in what form? Slope-intercept form. 2, graph the line. And 3, identify the solution. Okay, so there's a few different methods that we use to do systems. We are going to do each of them kind of the next few consecutive days. Today's solving by graphing. Okay, so you get 2 equations. You need to graph those straight lines on the graph. And then how do you identify what the solution is? That was not a rhetorical question. So after you graph them, how do you identify what the solution is to the system? Yeah, where they intersect. right? We said a solution is where the two lines intersect. Okay. I'm disappointed that our brains, I think, are somewhere else. I have a lovely wife and a beautiful son that I would love to spend all of my time with, but my brain is with you right now. So I would love the same respect. Okay. What is a solution to the systems where they intersect? It is a point, an XY. Okay. Meaning, let me show you. Okay. On number one, we're going to identify the equations as being in sloped intercept form, hopefully. Okay. These are both in y equals mx plus b form. Okay. The constant or the number by itself is the y-intercept. So that would be at -8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Draw my point. My slope, because x is by itself, the coefficient of x is what? 1. So 1 over 1, right? So 1 over 1, boom, boom. I'll just do a few dots so that I can get a graph that's relatively close to straight. Okay, and now I'm going to graph the next one. Okay, so the next one is y equals -2x plus 1. So what's my y-intercept? The 1. Okay, the y-intercept. So I'll put my first point at plus 1. And then my slope is -2 over 1, right? Because it's a whole number. So I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. Okay, now, I have a handful of rulers. I'm not super concerned with it, but you want to make sure your lines are at least straight enough to where you can reasonably assume which point we're intersecting. Okay, so what point are these two lines intersecting at? Are you guessing? No? I think it's 3, -5. No problem. Okay, so your solution for this, oh my gosh. Hold on. Okay. Oh no. It's jumping around on me. Hold on. Yeah, this thing's been nice and glitchy lately. Okay. So we said 3, -5. Okay. Now, going back to something that I talked about at the beginning, what is a way that we can check to make sure this is correct? Okay. We just go and plug it in. Okay. So I'm going to take this first equation, which is, I'm going to do it down below. I think you've got some room to do it on the side. Okay. But I'm going to take this first equation, this one right here. Okay. I've got y equals x minus 8. What am I plugging in for y? -5. And what am I plugging in for x? 3. And now I just simplify. I've got -5 on the left. 3 minus 8 on the right is -5. Is that true? Yes. So it works for the top one. Now I can just check to make sure it works for the bottom one. I've got y equals -2x plus 1. I'm plugging in -5 for y again. And I'm plugging in 3 for x. And then I just simplify. So I've got -5 equals -2 times 3 is -6 plus 1 is -5. Does -5 equal -5? Yes. So that is a good solution. Okay? For graphing systems, that's really all you're doing. I would like for you to try Yes, I would like for you to try number 2 on your own. I'm going to give you about 2 minutes. Of course, when I say on your own, I mean you and the person you're working with. Well, make sure you're still running. Okay. So is one pole there and back? How?
I know they have the white just.
Yeah. So.
They have that. Over one. I don't know if that's how
Okay, just from walking around. If you have graphing on your IXL skill plans, maybe that's where we focus on for the next couple weeks. Okay, you will have to do graphing on the state test. For you guys, you'll be doing graphing for the next 4 years. If you do something math or science, engineering related in college, the next 8 years. Okay, graphing will never go away because graphing is highly applicable. So just keep that in mind. Okay, if it's on your skill plan, my suggestion is to maybe focus on those because those will help with these lessons. All right, so let's talk about this one. A quick refresher. Okay, when we're talking graphing, so like on the last problem, we had a -2 x, right? And we said -2 over what? It was over a 1. Okay, so what that is rise over run, right? Rise is my up and down movement on my graph. Run is my side to side. Okay, so I went down 2 and then to the right 1. Okay, so on number 2, on the first graph, I have 1 over 2. Okay, you want your points to be on intersection lines. Technically, you can graph like a half point in a direction, but we don't need to do that. You can space your points out more, and that'll make it a little easier. Okay, we are going up 1 and then to the right 2. Okay, starting from where? 9. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 as my starting point. Then I'm going to go up 1 over 2. Okay, now if I go up 1 and over 2 again, what's going to happen? I'm going to go off the graph. So I can go the other direction. Okay, what is the opposite of going up 1 over 2? Down 1 and over 2 in the other direction. It works as long as all you created was a straight line. Okay, so that's the graph for my first equation. Okay, y equals -x plus 6. My starting point is going to be 6 at the y-intercept. Okay, how do we always know? This might not be something, well, let me just assume you didn't learn this, okay? The y and x intercepts are always identified as, like if I want an x-intercept, I just put 0 in for y, right? Because anytime I'm on this line right here, I'm not going up or down y-wise, right? Y is a 0. So if I need to find my x or my y-intercept, I could just plug in 0 to the equation. So a way to check if your y-intercept is 6 is I could just plug 0 in for x. What happens to x right there? It disappears, right? And then I'm just left with y equals 6. So that's why that number is always your y-intercept, is because you just plug 0 in for x, and the x goes away, and all you're left with is y equals whatever that constant number is. Okay, it would work with the top one too, yes? If I plugged 0 in for x on the top one, what would happen? Yeah, you'd have 1/2 times 0 is 0, so you just have a 9 right there. Okay. It works the other way for the x-intercepts also. We'll talk about x-intercepts and zeros at a later time. But negative x. What is that coefficient in front of the x? A negative what? Negative 1 over 1. Okay. Please notice and take note. I don't know if you need to make a star, highlight, whatever you need to do. Okay. A negative slope has only how many negatives? If I just said the word only, one negative number, which means when I'm counting my slopes, if I go down 1, is that negative? Yes. So then which way do I need to go if I'm going side to side? Right. Okay. Notice I don't have a negative 1 over a negative 1. Why don't I have a negative 1 over a negative 1? What is a negative divided by a negative? A positive number. So if I have negative 1 over negative 1, that is not a negative slope. That's a positive slope. Right? So when I'm counting my slopes from right here, I'm going to go down 1, right 1. That's going to take me in the negative direction. Down 1, right 1. Down 1, right 1. Well, this is not horseshoes or hand grenades, so we want to make sure we get it. That's an old person joke, you know. Did you like it? You never played horseshoes? So horseshoes and hand grenades are like, you get credit for getting close. You don't understand those words? Now I'm just speaking like regular words.
No.
Okay. Okay. Yes. Okay. What is our solution? Negative 2, 8. From this point. Yeah, from the origin. Mm-hmm. Your values are always in relation to the origin because that's your starting point. Negative 2, 8. How can I check? Yes. Substitute them in and then check to make sure that those equations are true. Okay. On number 3, I will do this with you. All right, so on number 3, what do we notice about these equations?
It's more difficult. It's on the other side.
Y'all all nailed it. Yes. So these are not in slope-intercept form, right? These are not in slope-intercept form. So actually, last night I'm tutoring like 4 geometry students from all over the state in algebra. Okay. And last night, actually, this is what we were working on. And I taught them the zeros thing that I just was talking to you about because it's really easy to just find your x-intercepts and your y-intercepts and then not have to do any other graphing, and you don't have to do any rearranging, but we'll get there. But how do I solve for a slope-intercept form on the top one, let's say? Negative 3x plus y equals 8. Can we be more specific? Because it is not gymnastics. It is not just as easy as doing a back handspring, and now the things are in different places. Do some algebraic gymnastics, Brian. Solve for y right here for me, for number 3, the top one. What is, hold on. Yes. Yes. Plus 3x. I thought you said plus negative 3x. It's okay. Plus 3x is what Emma was saying, right? Okay. So the reason that she's saying that is when I say solve for y, listen, I see a handful of you checked out. Okay? Totally your prerogative. There's nothing I can do to check you back in. But you're the one that is failing yourself. Okay? Check in. Lock in. Take yourself seriously. I'm running out of motivational speeches. This class was killing it at the beginning of the year. And whatever the opposite of killing it is what we're doing right now. Yes. Here's what I'll tell you. One of the things I worked on this weekend was a seating chart for this class. I'm very concerned with the focus overall. You can, I see some. Okay. If a seating chart is that serious to you, there is one easy way to fix it. Okay. My son screams and screams and screams at me to not make him do something, and I'm like, well, just wash your hands and then you can have your fruit snacks. No. Okay. Well, there's an easy solution to this. Just wash your hands. There's an easy solution to this. If you don't want a seating chart, tighten up. Be a better student. It's really easy. Whether you know what's going on in class or not, the reason you don't know what's going on is because you get confused and then you check out. Okay? I am not a motivational speaker. So me coming in here and giving you a rah-rah speech every day is going to fall on deaf ears eventually, if it has not already. Okay. Please turn to someone you're sitting close to and explain explicitly what does it mean when the teacher or the problem is asking you to solve for y. That is what I'm asking you to do right here is solve for y. What does it mean? Discuss. All right. Somebody tell me. What does it mean to solve for y? So, okay, that's a great way to say it. Yes. Take away y's friends. So who's y's friend in this problem? The negative 3x, right? So we're trying to get y all by itself. Okay. So Emma already told us how. We're going to add 3x to both sides. Okay. If you want to take the whole thing, you've got to add or subtract. Okay. If you want to take the whole thing, you got to add or subtract. Okay. When you're trying to split it up, is when you multiply or divide. Okay. Y equals. That would be great. Actually, 3x plus 8. Okay. Are we done? Are we done with getting y by itself? Hopefully, we'd say yes. Unless you see something I don't, in which I will add that to my list of things to talk to my therapist about. Okay. It's okay. It's just a coping mechanism. Okay. I love the enthusiasm. Okay, so what is our y-intercept? Our y-intercept is 8. No. We don't need to. Nor can we. What's my slope? Slope is 3 over 1. Okay, so because I can't go up 3 or I'll go off the graph, I'm going to go down 3, which means I have to go down 3 and left 1. Okay, negative over a negative because that's a positive. So down 3, left 1, down 3, left 1, down 3, left 1. is that a positive slope? Is it going up and to the right? Yes, it is. It's on the left. It's existing on the left side of our graph right here, but it is going up and to the right. Okay, I would like for you to rearrange the bottom equation and see if you can graph it. I'm going to do it up here. Don't look up until you're ready. To do in freehand? Yeah. So you feel like that was better? That's interesting. Well, so Audrey, I don't know if you know this, but you're allowed to do that on your own. So I'm giving you these notes, and you could take these notes and still create your own. Oh, so we were just talking about having more fun.
Well, we like to enjoy taking notes while you take the notes.
Let me see what I can do. We'll freehand graphs. Per Audrey request.
No, I remember something.
All right.
And then I got
So what's your solution? What in the world is wrong with me? Sorry, I messed up. I'm a silly goose. I messed up. So if you were just copying me, you messed up too.
Really? See, I knew something was off.
I trusted you, Mr. Bennett.
You can still trust me, but
It was just one of those.
Oh, I trust you on 15 months.
That is not good.
I don't think I can trust my every math teacher this much. Should I, Mr. Bennett?
that's totally up to you. I can't tell you how to feel.
When you shoot a chalkboard, like people used to use back in like a long time ago, and
My first year teaching, I had a chalkboard. Yeah. I mean, there's the overhead projector up there. Y'all don't even know. Y'all are all looking on the ceiling like it's attached. Look at this green box over on the left up here. So that is called a light overhead projector, and teachers would have transparencies and vis-a-vis like expo markers. Okay, yeah, they were wet erase. Okay, and they would have these like see-through pieces of film, and that you do them on. And so, like as a teacher, I would stand right here, basically, and write on it, and it projects on the screen around me. They used those in elementary school? That was what, like
4 years ago.
okay.
But they were a lot more like modern, but like and it was very delayed. It was quite easy to
Oh no, that's an Elma. No, that's not a camera. That is a mirror projector.
Yeah, I did that.
Y'all are thinking of a dot cam. I have a document camera. What Miss Clark used last year. Yeah. What Miss Clark used was an actual digital camera that uses light and mirrors to project the image up onto the screen. Yeah. I'll. It's funny that you said that's sciencey because this is obviously way more advanced science. But yes, agreed. Okay. Number 4. Please do this one on your own. Oh, no, sorry. I didn't finish. I got distracted talking about old stuff. Okay. I didn't say that. 1, 2, 3, 4, 5. -7. Please do number 4.
Have you heard the slope song?
Have I what? What?
Have you heard the slope song?
No, sing it for me.
No, a couple of nights ago, one of the best thing ever. Mr. Bennett, did you ever teach on one of those boards where it's like recalibrated? You never like
Touch the buttons. Yes, I hated it.
That was my favorite thing. Our teachers would let us do it before they would never let us do it.
You had to use the pen, and it would be like touch here,
Oh yes, and you would say
touch here, touch here.
My elementary school was
so what? I've never been to a top board. I know, I remember that. It's
I didn't wear my hoops today.
Is this the slope song? Oh, somebody made a fancy one. This is like late 2000s emo music. Okay, we should be working on number 4.
Uh-oh.
Can I use your car?
My car? Sure, you gonna fill it up with gas?
My mom got up a horse meeting or a car Cherokee, and it was $70 for a horse.
Yeah.
I know this is
Yeah, your car's the one.
All right, stalkers.
What model is your car?
It's a Subaru Crosstrek. It was my wife's car. Actually, when she had it, she was not a mom yet. So no, no, my wife has the mom car. It's a Subaru also. It's a Forester. I had to sell my Jeep. So
Why'd you sell your Jeep?
no, it was a Grand Cherokee. It was beautiful. It was beautiful. Yeah, I really miss my Jeep. Somewhere in Dallas. I don't know. I had to sell it because it's a long story. Sure.
I want a Honda Civic Type R 2023, or I want a Honda Civic Sport.
Nice.
In the color gray.
Sounds fancy.
Yeah, but my parents said my mom's gonna give me her car money, and so she's gonna buy me something.
Nice.
Some scammers told me that I want a PS5. They told me I want like a Chevrolet like Bernadette, and I was like, doing that.
That sounds really cool, Brian. You would have been very happy, I bet. All right. So what did we get for number 4? Anybody? So I heard a couple different answers. Did anybody get anything other than that?
What? They're the same.
So if you solve the top one for y, okay, you would subtract x from both sides. That gives me 2y equals negative x plus 4. Then I want to get rid of that 2. Okay, so again, if you want to move the whole thing, you got to add or subtract. But if I want to split them up, so if I want to split that 2 and that y up, what do I need to do? No worries, nothing better than asking a question that nobody heard. If I want to split the 2 and the y up, what do I need to do? Divide by 2. Okay, now when I divide or multiply, you have to do that to everything. So I'm going to divide the 2y by 2, the negative x by 2, and the 4 by 2, which is going to give me y equals negative 1/2 x plus 2. Now what does that look like? That looks like the second equation. Those are the exact same line. All right, here's what we're going to do. We are definitely going to finish out all of these notes. I think this shouldn't be offensive to anybody because you're here to learn. I think it's very obvious that we need to practice the rest of these. So you will not have homework this evening, but you will do 5 through 8 right here, okay? On Thursday, we will do, in a way, yes, a crime scene project. So think about what group you want to be in. The crime scene project will be Unit 3 stuff. Y'all just pick. I would like for no one to do it by themselves, so at least 2. I would like for it to be, I'm going to cap it at 5, 2 to 5. Okay? More than 5 is too many because then there's just people sitting around. Now, I did not do this last time for this class. I actually did for pre-algebra, but I'll keep this on the recording. It's fine. No, it's not a big deal. This will be, you will have a daily grade, okay, for the time that I'm going to give you in class. So you will have basically like a working grade, okay, more or less, okay, that will be kind of like a homework grade. The overall grade for the project will be a test grade, and then you will also have a peer grade, okay? I will send out a Google form. You will rate the work that the people in your group did. I used to think doing something like this was silly because I figured most students would just give everybody good grades. That is not the case. And pre-algebra was very honest about the people in their group, mainly because if they, let's say their group as a whole got a 75 on it because they didn't do super well, those people that were working really hard on it were pretty upset that the people in their group didn't help because they didn't get a good grade to begin with. So keep that in mind, okay, with who you're picking in your group. When you get into group picking is always an interesting science or psychology. When I was in high school in AP Physics, we had this project called a Rube Goldberg or a marble project. You didn't do one like this. It's crazy. So, and you'll do one when you get to high school physics. You'll do one. But basically, you had to build this contraption where the marble had to go for exactly a minute. Okay. Yeah, a minute. And it had to stop within plus or minus 3 seconds of a minute. So anywhere from 57 to a minute and 3 seconds. Okay. And you had to have like 5 different Rube Goldberg, which are like chain reaction events happen. You had to have an elevator lift, all this stuff. Like you had to build it. And the teacher gives it to us in September, and it's not due till February, right before, or it's actually due in March, right before spring break. And she said every year she tells people, don't pick people in your group that you are currently dating. Don't pick people in your group that you are currently interested in dating, because by the time the project is due, you will hate each other. And every year, at least half the groups would have a boyfriend girlfriend, a girlfriend girlfriend, a boyfriend boyfriend, like people pairing up with people they were interested in romantically. And by January, they're in the physics teacher's classroom begging to switch groups because they cannot stand to be in the same room as the other person. So, as a teacher, it's like I feel like sometimes I'm talking and the sound doesn't go past here, because I'm just like, guys, be smart about who you pick. And everybody's just like, oh, I'm going to pick to be in this group with this person, even though in 3 weeks I'm going to hate them. Okay, so anyway, that doesn't apply to here because this project won't last longer than a week, which is about the same length as some of y'all's relationships. So, all right. You should be working on 5, 6. Canes or cake? Oh. You should be working on 5, 6, 7, and 8. Some of you are making me consider giving you homework, which is really easy to do. Yeah.
My mom made me take like that. My mom was like,
So, top one, we're trying to get one right. So, what's that? So, the whole thing.
I'm so good at that.
You said you were going to subtract the x, right?
I'm so good
So I'm
at
going
that.
to take x over some minus x. So this is why when we did this last semester, I felt right there. You don't want to do x over. You draw a line on your equal sign, and that'll tell you which side. Okay.
My family and like neighbors family, right? We went to Spain.
It's negative x minus x. They both have negative. So I'm going to this down. We've got 3y.
He was like walking by.
Okay. And now what's the last thing I need to get this y back? So if you want to move the whole thing, you gotta have a subtract. If I want to split this up, I only divide everything by 3. Yep, that's why we're in there. So it's going to be negative x over.
And then like I got his
And then whatever negative is divided by 3.
I don't know what to get one of his babies. No,
And y is negative.
and he has a baby.
Oh, that was
Slow finish, that's fine. That's too slow. Rise. Okay. This. Why you use
because I'm very used to cooking the toilet, so I know how to got every single and then she brushed her teeth.
from that point,
No, I didn't tell her until we got back to the US. So like a month went by. She got sick and she skedaddled to the
I would do that all the time.
I had an extra
Now,
It's not good, huh?
you can.
It was funny.
You got 3 points.
Ew, oh, that's right.
Okay.
Is this right?
I'm gonna write this down. Oh my God, you're right. Oh. Well, you guess. I know. I guess she was like, no. Wait, what do you do? How about you're driving my phone?
Yes, yes.
Miss, I want to go to that.
Nothing can that's not so easy. And the kid's mom is a teacher.
Wait, the oh, I read this. You're still speaking. Bro. What even is that? It's let me read it. Where does it go? Lips? Oh, Sal. Universal. Wait, that's French. That's French. Yeah. I like my mom's pour though. It's better. Like your what?
No, but it's
I
not.
like pour. Yes, it's very oh, yeah. I was right. I told you.
That's not right. Oh, wow.
Oh, I'm just kidding, guys. I don't know how to do these. The numbers will be on
So it's because we haven't finished solving. We've got to get y by itself. So like on this first one, sorry. So on the first one, we need to split the 3 and the y up. You better have to divide. You have to divide everything by y equals negative x over 3, which is the same as like negative 1 over 3. And then 15 divided by 3 is 5. So then I can this one, you have to do the same thing. You just gotta get rid of the negative. It might end up being the solution. Yeah. But just to finish that one out. And then you would need to divide by negative 5 right there.
Mr. Bennett, I was doing this one, and the points aren't intersecting like specifically, but I don't know what that would, if that's like not.
I remember the schools to me was like there was no yes, yes. It was just all aesthetic. It wasn't really aesthetic.
Check your math on the top one.
Okay.
35 divided by 5.
Is it negative 35 divided by 5?
What is 35 divided? Look at me. Don't look at the paper. What's 35 divided by 5?
Is that 7?
How do you do the y?
Say that again. Yeah, so that's just a y-intercept then. So you'll mark negative 7 on the graph. So where negative 7 is y? Okay, so make a point right there. And now your line is just a horizontal line. Yep. Because you don't have an x. Or you don't have a slope. Yep. Say that one more time. If it's a negative 1/3, then it would be down 1, right 3. Yep. All right, guys. I'll put 5, 6, 7, and 8 up there. So, have I played chess?
No one here understands that. Just talking straight.
Sure. I've been playing chess for a long time. I wouldn't say I'm good. I've watched the Queen's Gambit. So good.
I used to have those little like someone has a picture. Got my face to watch.
I will. I'll go back to 5 too if you need it. I could sit up front. No problem. I asked him if that was his Band-Aid on the front. He said no. So. Oh. Bruh, he didn't lose it.
If you didn't lose it, then what happened? You misplaced it?
Brian, are you really the one giving somebody grief?
Yeah, I am. Oh my god.
All right. Real quick, number 5 and number 6, please check. Really, the graphs are not as important as making sure you got the same solution as me. Make sure that you got the same solution. It's confusing me. Are we done with these problems on our notes? Because I'm not sure why we have our Chromebooks out. Okay, number 7 and number 8. My other suggestion for what you need to work on: solving. That's it. Solving equations. If you took pre-algebra, you solved equations in pre-algebra, allegedly. If you didn't take pre-algebra, you've just got catching up to do, but your previous teacher felt that you were equipped to do so. But it's going to take some work on your own. I was literally told yesterday in the training I had to go to that I should not spend class time teaching you to do stuff that you're supposed to already learn. To which I said, no, I wouldn't do that, of course. But
Mr. Bennett, did you lie?
I am more of an ask for forgiveness instead of permission kind of person. So, Brian, you saying that makes me feel like maybe I should change my ways.
Oh, no. It's okay.
You saying that makes me definitely feel like I should change my ways.
Maybe. Red Robin.
Red Robin, yum. That's what he's talking about.
Yeah, that's what For auto accident injury, 5430303, punch Every time I get an auto accident injury, I'm covered.
Every time you do?
Yeah.
Did I? Oh. Mine is just crooked. Just because mine's crooked. Just make sure that your solution matches.
Strap up, guys.
I always tell my dad this.
Why does not? You're just His dad scared me.
Why does everyone say that? It's not even scary.
It was not scary. It's just love.
Okay, there's the rest of them. Again, on your math skill plan this week and next week, solving equations, solving equations and graphing, I think are really important. Okay, slope-intercept form, standard form, any of these. If everyone would please grab their Chromebook. I just got a message from Miss Schultz. She's looking for someone's Chromebook. I don't know whose. Everyone, please grab your Chromebook. Check the serial number. How do you?
Bro, I know
Okay,
I don't have your
the serial number J5R.
Bro, know I don't know Adam's stomach. I didn't have her name on it.
So, okay. J, the barcode. Okay, the barcode. Serial number. Jerry, 5. Roger, Quincy, Henry, Michael, 3. Okay. Those are letters. Children. Okay.
Can I
Goodbye. Y'all have a great day. I will see you at track practice though.